Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper and I'm a postdoctoral researcher currently at the Helsinki Institute of Physics over in Helsinki in Finland, and I'm a cosmologist, so that means that I study the universe, the contents of the universe, how things evolve, how things interact, all of the cool stuff happening inside the universe. I love being a scientist. It's a really, really, really fun job. It has ups and downs, and currently I'm on and up with my research, despite being overwhelmed by a lot of things. It's a fun thing. And I love chatting to people about all of the cool things I get paid to research and all of the cool things that I like in science that are completely unconnected to my own research, like superconductors. So yeah, welcome everybody. As I'm sure some of you just noticed, I had a few technical issues at the beginning because I was moving my screens around. And as someone just said immediately, nice lo-fi music. Yes, I figured out how to put music into Restream, but also it means it's just an extra button for me to be aware of. And currently I'm still trying to streamline that with the music. But anyway, welcome everybody. Great to see you here. I see we have some of the regulars coming in and some new faces. So hello to all of the regulars. Great to see everybody joining and coming in and asking questions as always. Really great to see everybody here. If you're a first-time viewer, welcome. I hope you enjoyed the show. Please do subscribe if you haven't done so already. And for everyone here, leave a comment, like the video, share the link, do all of the usual YouTube things. It really does help boost engagement, and then I get more views on my channel, which means I get more people to tell about all of the cool things in the universe. And as always, a huge thank you to Paul for promoting me on Twitter. I don't bother putting out Twitter announcements, and every week Paul puts out the Twitter announcement for me, hyping up the streams more than I could hype them up myself. So yes, thank you everyone who really contributes to promoting the show and getting the word out. It just makes it so much nicer when we have more of an engaged audience, and it's more fun. What up? How are you all doing? Wonderful people doing today? Thank you for asking that. I hope everyone is doing well. I am doing pretty well. As I kind of just hinted at, I've had pretty busy week. I'm not trying to do too many things right now, but also I'm really enjoying my work right now. It's a lot of stuff. Not all of it is working. Most of it is not working, but I'm working on a lot of cool stuff right now, and I'm very motivated about several things at my work. So it's cool. It's a nice time. Busy but fun is my conclusion. And I'm very amused at Scott's comment here that your cousin was an elevator repair technician. Job also had its ups and downs. It's very, very funny. You have a question for me. Why haven't aliens come to our solar system yet? Great question. Okay, so before I get to that about aliens, it's a good question, and I'm happy to answer that. But currently on and up, what's up right now in your work? Let's answer that one first because I was talking about that. Honestly, nothing overly new. But it's like this week, I'm supposed to be working on a lot of codes and writing a bunch of papers about the codes and doing some research. Okay, I didn't realize your question was actually a joke, but thank you. Yes, why haven't aliens come to our solar system yet? They read the reviews and they got 1 star. I thought it was a serious question, and I am going to answer it seriously anyway. But I always appreciate jokes and puns and off-topic comments, so thank you for that. Did we prove room temperature conduction? Thank you. Going to come to that one as well. I'm making notes of this. But yes, what is happening that I'm excited about right now in my own personal work? Not something overly dramatic, but I'm working on a bunch of codes and a bunch of papers related to said codes, and it's just really cool. We can't really put the universe in a lab and poke about at it and do experiments with it. The way we study the universe is often by running computer simulations. So we put all our knowledge about a specific part of the universe in a computer, and we tell it to simulate what the universe would look like under these conditions, and then we compare this to what we actually see to see how well we simulated things. And it's really cool. And I'm currently working on 3 or 4 different, I'm working on like way too many projects, but 3 main ones, and all of them have different codes looking at slightly different things, but all related to this idea of you could have a phase transition in the early universe, like when you boil water and it gets these bubbles and then goes into vapor. You could have something similar in the early universe where you gradually get bubbles of the new phase, and this could produce gravitational waves, which are ripples in the fabric of the universe that we're hoping to see someday in the future. So that's very cool. And I'm working on different aspects of this, like generating the bubbles and comparing the bubbles to LISA data. And it's all very cool. And actually, Monday, Tuesday, and Wednesday this week were complete coding days for me. And every day I focus on a different code. And it's really fun. Like, this code does this. Doesn't work, but it does this. And on the second day, it's like, this code does this, that one does work. The third day, it was a different code. And then Thursday and Friday, I was working with other people, and then writing stuff about the codes that I'm working on. So it's just really fun. It's been a week where I've really enjoyed the research that I'm doing, and like seeing things coming together and seeing the computer spit out stuff. So most of the time it was wrong stuff, but it was spitting out stuff. And it's just been a week that I've remembered some of the things I enjoy the most about my research, and it's been fun. So that's why I'm currently on and up. Okay, so let's have a technical discussion someday when we get deeper into hardware and software of these simulations. Yes. So many years ago, when I was still doing these streams on Periscope, and I think I did one on HAPS as well, where I did an interactive stream where I actually loaded up one of the codes, did a screen share with like one of the codes running, and you all had to like give me versions of the universe, and we simulated it live. And it was pretty fun, but also I think that appeals to a very limited amount of people here. And I'm happy to do that again one day and just like walk you through the different codes that we're using and how we use them and what they do, because it is really fun. So we can do that someday. We're living in a simulation in someone's lab where the computer keeps spitting out the wrong stuff, probably. I mean, you can't prove that we're not in a simulation, but you also can't prove that we are in a simulation. So it doesn't affect anything whatsoever, but it's a fun thing to think about. Okay, so I know it was asked as a joke, but there was a question of why haven't aliens visited the solar system yet? And obviously the answer was because they read the reviews and it's only 1 star. But also, the universe is big. The universe is very, 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 very big and massive, and most of it is empty space. You know, we are 1 planet between 8 planets around 1 star, as we've established. But there are billions of stars in the universe, billions of stars in our galaxy, and billions of galaxies in the universe. So the universe is massive and big, and there's so much going on out there that you must think, you know, somewhere out there must be some type of alien life form, right? Maybe not, maybe yes. But then you also need to factor in the conditions that would. So, what would be involved in aliens visiting us? Well, first you need an advanced species that has interstellar technology and that is close enough that they could realistically send somebody to the solar system. Okay, so we are a pretty advanced civilization by some descriptions, but we don't have interstellar travel, which means we couldn't go visit anybody. So in order for aliens to come and visit us, we need an alien species that is more advanced than us. This means that they probably, just based on general ideas of how civilizations progress, they would probably have needed more time. So they would have needed their planet to form a bit earlier, for the conditions of life to be there. So there's a lot of criteria you need in order to get a species that is capable of interstellar travel. You know, you need the planet to exist for long enough. You need the right conditions for life. Mark, here in the comments, I let your first one pass. If you're going to be disruptive with your comments, I am going to mute you. I do not tolerate trolls or comments about my appearance, because that is not what this stream is about. So that is your warning. Yes, so we require an advanced civilization to have enough time. So what does this advanced civilization require? It requires a planet to be around long enough. It requires the right conditions to foster life. And both of these are already difficult. Then we need it to have advanced enough and actually developed interstellar travel. We're not there yet. And then we need them to be close enough that they could realistically come and visit us. And all of those 3 conditions means that it's very, 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 very difficult for an interstellar alien, or for different aliens, to actually come and visit the solar system. So in answer to the question of why haven't aliens come and visited us yet, my answer would be because the universe is vast and huge. And if there are aliens out there, they're very far away. And if there are aliens who are clever enough to have the technology to come and visit us, it's going to take a while before we're actually at a stage where this is going to happen, probably. Also, this is talking about aliens as an advanced civilization, but something else we can ask is, are there alien life forms in general out there in the universe? And there I would argue that yes, it's much more likely that the first encounter, personally, I think that the first encounter we have with aliens is not going to be with an alien civilization that's sending spacecrafts. It's going to be bacteria that we find on some moon, potentially even within the solar system. because it is much easier to form single-cell organisms than to form advanced civilizations, like interstellar travel capacity civilizations. So aliens have not visited us yet, to the best of our knowledge. We have no reason to believe that aliens have visited us. I personally think there is going to be a lot of life form out there in the universe, potentially even within our own solar system. I think the amount of species out there with technology capable to visit other planets is going to be very small. But the universe is big and vast, and if you wait enough time, everything is possible. But yes, aliens have not yet visited us to the best of our knowledge, and we have no reason to believe they ever have. And it would be very difficult for aliens to actually appear here, and I would be very happy to be proved wrong on that one day. Could they send self-replicating probes out? I guess they could, but then you'd also need yeah, I guess they could send self-replicating probes out, assuming that they have this type of technology. Then, of course, we are limited also by the travel speed. Are we assuming here that this intelligent species has developed faster than light travel? Because else it's going to take them a very, very long time to get stuff here. So yeah, we could potentially have, going way into sci-fi, an advanced civilization capable of space travel in a limited amount of time. They've got either faster than light travel or warp drives or something very sci-fi like that. And they might have self-replicating technology. So that could hypothetically be the case. But again, you need a lot of conditions a lot of boxes to be ticked in order to have such a species. And then still, if there are billions of light years away in a different galaxy, we're probably not their first target of place to come and visit. But hypothetically, yes, there could be self-replicating aliens out there in the universe, but there's a lot of conditions that would need to be fulfilled in order for this to be the case. Okay, I am aware of the superconductor question. I'm very glad somebody asked that. I'm going to come back to that. Does panspermia, life traveling on rocks from planet to planet or even interstellar, seem at all plausible? It actually could be. So obviously not like big life forms. Like we can't really hitch a ride on a comet, for an example. But if something came and destroyed the Earth, let's imagine a giant asteroid is heading to us, which it probably is at some point. Giant asteroid is heading to us, smashes against us with such force that it actually sends rocks flying everywhere, like it rips off chunks of the Earth. Now, these chunks of Earth that are ripped off could contain bacteria from our planet. For an example, tardigrades, which are tiny little species that can survive the vacuum of space. They can survive pretty much anything. So then these chunks of rocks of hypothetical destroyed Earth would have some type of life form in the form of tardigrades, unlikely to be humans. Now, if these chunks of rock ever got shot out with enough force that they could travel to another planet or go crash into Mars, then theoretically, yes, they could take with them the tardigrades or whichever other bacteria or whatever else is stuck to this chunk of rock. So this idea of panspermia is actually not so far-fetched, and there are people who actually think that not necessarily the original life forms, but the water that we have on Earth that is a basic building block of life on Earth could actually have come in a comet that crashed on top of us, on top of our planet. So while we haven't yet found any life forms hitching a ride on a comet, it's something that could feasibly happen, assuming the life forms can survive very, very specific conditions. So it's not too far-fetched. Was that the origin of life on Earth? Probably not, but also it is a hypothesis that people have. Wormholes would solve the big universe problem. Couldn't the advanced species create wormholes for travel? That would be very interesting. So the idea of a wormhole is you take two very different parts of space-time and you kind of bend them together, so you create a bridge where you can travel from one to the other without going the long way around. Kind of like a portal. If you ever played the game Portal, it's kind of like that, but across the universe. Now, to the best of our knowledge, wormholes are unstable. They are a theoretical object that we've never actually, a hypothetical object, sorry, that we have never actually been able to see or create. And even if we could create one, based on what we've understood of general relativity, as soon as something enters a wormhole, the wormhole becomes unstable and collapses. So we have not been able to figure out how, if at all, wormholes could be used for any type of travel. Now, of course, if we have we're talking about a very advanced civilization. Now, at this point, we've decided that they have interstellar travel, they have potentially faster than light spacecrafts, And if they've reached a point where they've understood physics so well that they can create wormholes, then hypothetically, yes, they could use that to visit us. Now, if there are species that can create wormholes, they are much, much, much more advanced than us in a lot of different ways. So that would be an interesting encounter. And that is a possibility, but based on our current understanding of the laws of physics, that's not likely. Of course, we might be completely wrong, which would be fun. Supposing, for sake of argument, that aliens have been visiting Earth, would they not communicate solely with world governments, not as common peons? Well, that depends. Okay, so going again on this idea of advanced species with interstellar travel capacities and faster than light travel or wormholes, either way, very advanced civilization. By the time this very advanced civilization comes and visited us, what would they be interested in? Would they be interested? Are they here to study us? Are they here to befriend us? What is the argument behind having these aliens coming here? And if they did come here, then who would they talk to? Now, from our perspective, maybe the logical thing is speak to world leaders. But just think about the world leaders right now. Pick any country and think of the world leader. Would you want them representing the human race in diplomatic conversations with aliens? Is there any world leader that you would nominate for this job? Because personally, there are no politicians I would trust that job to. There's no single person I would trust that job to, right? And a culture or a society, civilization that has all of this advanced technology might have moved past a somewhat hierarchical societal structure that we have here. So trying to word this in a way that doesn't lead me onto one of my usual like anti-capitalism rants, but if a species is technologically advanced enough to come and visit us, it's quite likely that their civilization will be vastly different to ours. Would they have world leaders? Would they have one person in charge of doing this? Would they be a science team on board doing science reconnaissance missions? And then would they perhaps want to speak to scientists? Would they perhaps want to see how the average citizen of Earth lives? It's very hard to guess. So, yeah, if they'd arrived in 1970s, they could have spoken to Carl Sagan. Potentially a very good choice at the time, yes. But it's very, very difficult to pick, like, who would you want today representing the human race? And yeah, it's a very difficult thing to think about. Like, who would you pick? Who would you pick to speak on behalf of humanity? There's not many people who come to mind. So yeah, I think if aliens, this hypothetical alien species that we've said has either wormhole technology or faster than light travel, I think they perhaps would have moved past the need to speak to a world leader. They would perhaps have a different priorities when communicating with people. Let's leave that one at that. Okay, tardigrades will outlive humans. Yes. In high school, teachers told you that scientists were able to send a single particle through artificial wormholes. So by artificial wormholes, what people usually mean is wormholes created on a computer, so a simulation of a wormhole. And in a simulation of a wormhole, you can send massless things through. But as soon as you send something with a mass through, it collapses, to my knowledge. So yeah, wormholes are not a thing that we have been able to create just yet. I think they just take over a major social media platform and turn it into their alien communication mouthpiece. Well, that is also terrifying. I mean, okay, let's say again, aliens are here, and instead of speaking to our world leader, they commandeer a social media platform. Which one? Are they going to take the one formerly known as Twitter? Because, oh God, I hope not. Blue Sky, run by another billionaire. Meta, run by yet another billionaire. Maybe a decentralized one like Freddy, and then nobody would believe them because Freddy is full of shit posting anyway. I love Fediverse. So yeah, I'm not sure if I would prefer them to take over social media or to speak to a government. Both of those sound like terrifying options. Creating wormholes would mean creating wire holes. That's such an outrageous concept. Yeah, the whole idea of wormholes is just mind blowing. Like you create a hole in the fabric of space time and a separate hole. It's like this portal, and you just bend space time or put space time together in a way that you can jump from one place to the other. It's baffling to think about. Scientists baffled by wormholes, very much the case. Yes, would need to be a council of many different types of people. Yeah, maybe that Heard recently about the dark forest philosophy where you don't shout out your location when you don't know what else is there. Yes, there's also that, right? We are a very, 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 very loud species. We are shouting out into the universe. And we're sending radio signals. We sent Voyager. Voyager 2 is now like outside of our solar system, or not quite outside of our solar system, but outside of the influence of the sun's heliosphere, or outside of like the flares of the sun. It's really far out there. We lost communication with Voyager recently, but then we established it. And that's a new level of, if you think you fucked up at work, did you fuck up so badly that did you mess up so badly that you got one of the best telescopes we've ever sent out to the universe to look away from us and lose contact with it? Because someone did that in early July. It's okay. Voyager has correction mechanisms. It 3 times a year points back to Earth just in case something like this happens. But for about 5 weeks, we lost contact with Voyager because we sent the wrong command. Anyway, yes, we are a very, very, very loud species, and we are very much advertising to the universe that we are here. And we are doing this without any type of defense mechanism around the planet, without any type of escape plan. We're just like, hi, we're here. Perhaps we want to question if there are other species out there that are paying attention to us. Do we really want to loudly be advertising that we're sat here? Yeah. So this is the Dark Forest idea, and it's part of the Three-Body Trilogy as well. It's an idea that comes up there where you don't shout your location when you don't know what else is there. There was a very cool like short story that I read at some point. I think it was actually a Tumblr post. And it's like, we've been sending these signals for years, never hearing anything back. And we keep sending our stuff out into space. And one day we get a signal back. And the signal back, so, this is a story, this is hypothetical, this is like fantasy. So one day we get the signal back, and scientists spend ages deciphering it. And once they've deciphered it, the message just says, be quiet or they'll hear you. I thought that was really cool. Like, the first message we get could, like this story where the first message we get is a warning to shut up because the others are listening. I thought that was a very cool post. And it was one of those things that I read once and then the post disappeared. I've never seen it again. But that idea stuck with me. So yes. Yeah, you can tell I'm excited when I start cursing. Honestly, I curse a lot most of the time. I hold it back when I'm doing my live streams because I try not to curse too much on my live streams, and I also try not to curse too much at work because I know there are people at my work who don't like cursing, and just for whatever reason. So I actually try not to curse when I'm at work or when I'm on my live streams. But otherwise, I am bad mouth. I curse a lot. And if I'm with somebody who is cursing a lot, it has kind of a knock-on effect. So yes, you can also tell like my stress levels with coding. You can tell how stressed I am based on how much I'm shouting at and insulting my code. Yes, there were days this week where the cursing definitely increased substantially. And the good thing about speaking multiple languages is cursing in multiple languages. That tea is still too hot. That mug is a very good heat conductor, and it keeps my tea hot for a ridiculously long time, which means it's not a conductor, it's an insulator. Yes, that mug is very good at keeping my tea ridiculously hot. You have my stream in the background when you're processing astral photos. That sounds very, very cool, like a lovely mix of astral, cosmo, and space in general. And astral photos are very, very cool. So that sounds like a very nice hobby. Like, I've taken a few astral photos with aid of my telescope, and it was amazing. And it's something that I feel like if I had time, I would get into and take amazing space photos if I could. So it's a very cool hobby. So I'm glad that you're processing astral photos while listening to this stream. That sounds like a really, really nice combination. Blame your parents for cursing? I absolutely do, yes. Cursing runs in the family. Shouting at your computer will get more interesting with AI. Soon it will start shouting back. Okay, here we go. AI is not coming anywhere near my research or my computer code anytime soon because I don't think using a glorified chat predictor counts as artificial intelligence. It's as intelligent as a bloody parrot. I don't want a parrot writing code for me. I don't want AI writing code for me. So I'm happily shouting. I'm going to be like very much old-fashioned, the stereotype of not adapting to new technology. I am going to refuse any AI or machine learning that comes my way until I absolutely have to adapt. In the meantime, I'm happy to shout at AI because, I don't mind having an argument with a chat predictor, but I don't see it as anything useful or worthwhile investment of my time. That said, there have been some very useful applications of machine learning and machine learning type algorithms. For an example, there was a breakthrough in detecting breast cancer cases recently thanks to a machine learning algorithm that can process images faster than human skin and flagged a few for detection, and it just speeds up the process. And I think that is a very cool application of machine learning. And we should be very clear that that is machine learning and not artificial intelligence, because artificial intelligence implies some type of intelligence. ChatGPT has no intelligence, it's a parent. Anyway, yes, if you mention AI, you're going to get a rant. Yeah, stringing together crosswords that don't exist to create new ones is really fun, especially if you start getting creative. I think one of the funniest string of like it wasn't even a curse word, but somebody was cursing and shouted the phrase "the mother of the chicken doesn't run enough." It's like the what of the what doesn't what now? And anyway, that stuck in my mind. So yes, inventing random curse words is fun. I just want a cyborg to clean my bathroom and chores, please. Yeah, when yeah, I think there are a lot of potential future uses for AI and robots and machine learning. I just think it's still a very much a future thing and not a now thing. You know, the idea of inventing robots to take humans' jobs is to take jobs that humans don't like doing, so that then you can free up people to, create art and do more cool things and make music and listen to stuff and tell stories. And instead, we're training AI to replace the storytellers. It is nonsense. It's like humans are designed to sit around a campfire telling stories. We should make robots that allow us to not have to do bad jobs, and so that we can sit around campfires and tell stories. We don't want the robots to be the storytellers. This is literally not what humanity is designed for. So yes, getting AI or machine learning to replace screenwriters or to replace artists is absolutely ridiculous. On that note, if it's not abundantly obvious, I very much support the workers' strike, the writers' strike, and the actors' strike in the US, because obviously I am very much pro strikes and pro unions. Okay, rants aside, as everybody knows, AI is a topic that it's easy to get me to rant about. You just mention AI and the rant comes out. Hey Savant, great to see you as well, as always. Okay, so imagine the Terminator cleaning your toilet. Yeah, that would be an old sci-fi story. That would definitely be an interesting angle to take on that. Okay, so there was the question early on, and I was expecting it, and I'm glad you asked. Superconductor. Okay, so let's talk about superconductors. This is not at all cosmology related, but it is an amazingly cool topic. Bit of context. Let's wrap up. Let's go back. I assume that is there a trade union for cosmologists? Like, not for cosmologists in general around the world, but there are different unions at universities. I am part of my union at the university, which is for teachers and researchers working at universities across Finland. And there are usually unions. There's also a student union, and there are unions for different people at the university. And it's usually done more over like researchers rather than cosmology specific. So yes, there is a union for researchers at my university, or researchers at universities in Finland, and I am part of that union. And to everyone here, if you're not part of a union, you should join a union. Okay, superconductors. Let's start with the first question. What is a superconductor? So a superconductor is a type of material that conducts electricity, that moves electrons through it with barely any resistance. So anytime you're moving electrons around, you're creating electricity. Electricity is just moving electrons. And this requires a material that doesn't have too much resistance. The less resistance, the more conductive a material is. And there is always going to be some type of resistance, right? Except if you have a superconductor. A superconductor is a material that has basically no resistance. So electricity can just move through it extremely quickly. Now, this is very cool. And Another very important property of superconductors is they block magnetic fields. This is important because if you put a magnetic field close to a superconductor, imagine this ball is my superconductor. Normally, if it's not a superconductor, like just a normal metal, the magnetic lines go through it. The magnetic field just goes through it. But if this is a superconductor, the magnetic lines, the field lines, are just going to go around it. Like they cannot penetrate the superconductor. Why are superconductors important? So superconductors are important because they have zero resistance, which means it's much faster, much easier, and much cleaner to move energy through them. If you've ever had an MRI, the magnetic resonance imaging, that uses superconductors because then you can like avoid divert the magnetic field in the direction you want it to go in. So other potential applications of superconductors are things like levitation, magnetic trains, for an example, levitating train on top of a magnet, very cool. And just in general, it could speed up computational stuff, it could advance a lot of technology. Big problem with superconductors is that normally they require very, very, very low temperature or ridiculous amounts of pressure, usually both. Now, I know I talked about this last week. I just assume that people, I'm doing the recap in case you didn't tune in last week, just repeating it this week. So, yeah, superconductors have a lot of applications. They're very, very useful, but they usually work at either very, very, very low temperatures or very, very, very high pressures, often a combination of both. Now, something that is considered like the holy grail in material science would be a superconductor that works at room temperature. Because if you have it working at room temperature, you don't need to cool it down. You don't need to change it, but room temperature and room pressure. You wouldn't need to change the pressure. You wouldn't need to cool it down. It's like literally just a piece of material that conducts things very nicely. So why do superconductors block magnetic fields? I was really hoping that nobody would ask that because it is a great question and it's one that I always find difficult to explain. But it's to do with how the structure of the metal moves electrons through. It does it in a way that doesn't allow magnetic fields to enter. And I cannot give a better explanation than that, I'm afraid. It just blocks it. In the same way you can have some things that block infrared, for an example, or block different types of the electromagnetic spectrum. Low temperatures or high pressures. That's strange because high pressure is usually associated with high temperatures. Yes, it is high pressure. Yes, it should be high pressure. Yes, either low temperature or high pressure. Difficult to work with. Yeah, so you can have some materials that block different parts of the electromagnetic spectrum. Like you can have a material that is invisible in infrared. You can have a material that is practically invisible in visible light. You can have materials that are basically invisible to not even invisible, they just repel magnetic fields. So, okay, a bit more technically, when you reach a superconductive level, the electrons can move through it so freely that they basically generate their own magnetic field that is repulsive to the magnetic field outside. So the way they repel the magnetic field is by creating their own that cannot come together. So it repels the magnetic field. And it's something that is always very confusing for me. I spent a while this afternoon staring at figures of superconductors, like I need to understand this, but yes. We are talking about the Meissner effect. Yes, the Meissner effect is this effect of blocking the magnetic field, and the Meissner effect is a very, very important characteristic of superconductors. So there must be some superconducting materials that don't block magnetic fields. No. In order to be a superconductor, it blocks magnetic fields. This is, if you have a superconductor, it blocks magnetic fields. If it doesn't block magnetic fields, it is not a superconductor. So it is the telltale sign of a superconductor is that it completely blocks magnetic fields, and this is something known as the Meissner effect. And this is going to be very important. Let me just check that I did not mix things up there, and I'm just rechecking the Meissner effect because I read about it and now I might have it backwards. Yes. Okay, so the Meissner effect is really just like expelling the magnetic field of a material. There's no magnetic field going inside. Superconductors repel the magnetic field. As soon as an element is superconducting, it repels the magnetic field. Okay, So it's to do with the way it creates its own and pushes it outwards, but it's very difficult for me to explain because this is not cosmology and not my topic. And the last time I actually studied magnetism properly was in my undergrad, which was way too many years ago. But the cool thing about superconductors, they have a lot of technological applications. I've just seen the question about Euclid. I'm making a comment of Euclid because that is also a fun one to talk about. So superconductors have a lot of applications. It's a very, very nice thing to have hypothetically, but one big problem is that they need very low temperatures. So as I was saying just now, the kind of holy grail in material physics is to find a superconductor that works at room temperature. Okay, so this is very cool. Now, coming back to this, there's a question that makes sense to answer first. How do maglev trains work? Don't they need superconducting magnets? Excellent question. So there's another thing we can talk about in magnets, which is known as diamagnetism. And diamagnetism is a property of a metal or a material in which it minimizes the magnetic field. So it doesn't completely repel it, but it reduces it substantially and kind of mitigates it. So superconductivity and diamagnetism are very, very similar in that they both reduce the magnetic field in an object. One way to think about it is superconductivity is a state of being, like a state that the object can be in, whereas diamagnetism is a property that the object can have. So everything that is a superconductor is also a diamagnet, but not every diamagnet is, or not everything that has diamagnetism is a superconductor. The big difference is diamagnetism is the property of reducing the magnetic field, which obviously includes repelling it completely. But you can have a diamagnet that has very much blocks the magnetic field, but not completely. It doesn't completely block it, it just greatly reduces it. So I'm going to draw a very quick and badly drawn sketch. So imagine you have these two objects here, these nice objects, and you have a magnetic field going through. I'm going to label one as superconductor and one as diamagnet. So we have the superconductor here and we have the diamagnet here. So now I'm going to draw some magnetic field and show you what the magnetic field does. So just bear with me a minute whilst I'm drawing magnetic field. Okay, so first off, you have your magnetic field here coming into your superconductor. This is an S. I know it looks like a number 2. It is an S. So you have your magnetic field lines coming into your superconductor. What they do is they go around the outside. They are not allowed in any way at all. So they go around the outside. Now let's take this magnetic field and put it into the diamagnet and see what happens. Just drawing it again here. Okay, in the diamagnet, you see the magnetic field lines do go inside. Let me see if I can get, there we go. So here they went around the superconductor, and here in the diamagnets, they go through it, but they're very, very weak. You see, instead of being a solid line, I've just drawn the dotted lines here. So they can go through it, but they're just extremely weak. Whereas here, they're very, very strong. They're just completely avoiding it. Now, the reason this is important is, as I just said, every superconductor has diamagnetism. Not every diamagnet is a superconductor. Then the question of how do maglev trains work? Maglev trains, I believe, work based on diamagnetism. So there is enough attenuation, enough dampening of the magnetic field that they can almost repel it, and you get some type of levitation. But it is not a complete superconductor. And let me just check that that is how those trains work. But that should be the case. Yes, 2 sets of electromagnets, one to repel and push the train up. Yes. Okay, so not a superconductor. You're distracted by my letter S. Yes, sorry, I drew that very quickly. I have 2 types of handwriting. My handwriting is either really pretty and legible and fancy, or it is the complete opposite and there's no in between, and it completely depends on how quickly I'm writing. And if I pay attention, I write very fancy. If I don't pay attention, you get what you get. Okay, permanent magnets. Let's see, where were we? Okay, so the material just ignores the magnetic field like dark matter would. Exactly, and coincidentally, look, it's called dark matter. It's called DM. Fun fact. It's completely unconnected. I just happened to write it like that. So, every superconductor has diamagnetism. Not every diamagnet is a superconductor. The reason I keep repeating this will be clear in a minute. But I'm just going to take a diversion on a fun fact. There are some species of frogs that exhibit diamagnetic behavior. This is very cool because you can make them levitate. There are some frogs that when you put on a magnet, they actually levitate. And this levitation is because of the way it's cancelling the magnetic field enough. It's kind of creating its own field to repel it, but not enough to completely stop it from going through, just to reduce it. And this means that the frog can actually slightly levitate. So there have been very cool experiments where people have made frogs levitate. Like, but you don't do anything to the frog. The frog does not care in any way. But you just turn on a magnetic field to a specific like potency or strength, and you can make these frogs levitate. So some frogs have this diamagnetic property. They are not superconductors, but they can levitate. So the trains that we have so far with magnets rely on this principle. Okay, so why am I telling you all of this? This is not at all cosmology, other than it's very cool physics. Right, the levitating frog is so cool. And every time I read about it, I'm like, wow, this is so amazing. It's just physics at its finest. You take a frog, put it in a magnetic field, and it levitates. And you see, this is one of the things people sometimes come up with crazy conspiracy theories about physics and about the world. It's like, you don't need to. The world is so ridiculous already the way it is. Right? We have levitating frogs. This is incredible. Yeah, it's just amazing to think about the fact that we're in a planet that has this type of thing. There are more species of plants and animals than we have been able to investigate, and there are so many cool things. There are shrimp that can see 11 colors more than we can see. What do they need that many colors for? They're at the bottom of the ocean. Yes, there are so many amazing things on this planet, and we know a very small fraction of them. And one of the things we've been able to see is levitating frogs. And I absolutely love levitating frogs. It's just such a cool idea. And we are way off topic, but I was looking into like diamagnetism before the stream, specifically to talk about something actually like current. And then I was just thinking about levitating frogs again and how cool it is that we have levitating frogs on this planet. I should have downloaded a video of the levitating frog, but I didn't. I'm imagining a future where high-speed transport is where we sit on a frog and ride it down a levitation track. I mean, this is the future leftists want. Riding on levitating frogs instead of flying. This is the future we want. Okay, on topic. Back to the topic at hand. Now that I've done this side thing of levitating frogs, you'll see it's actually semi-relevant. So, the reason superconductors are in the news right now is that a couple of weeks ago, a team of scientists in Korea put out a paper that has not yet been peer-reviewed. It's just on the preprint server, which means no peer review yet. But in this paper, they claim to have found a room temperature, room pressure superconductor. So, yeah, YouTube searching for levitating frogs will help you out here. Please don't do that now. Like, stay here. Go look at levitating frogs afterwards. Don't all leave the stream to jump on levitating frogs right now. Save that for 15 minutes from now. So, there was this announcement very recently by a team in Korea of room temperature, room pressure superconductor. This would be a revolutionary discovery. This would be amazing. And there's so many things we could do with this. And it's with lead infused with copper in a specific way that they claim makes it a superconductor. This is amazing. But there is one big problem. Or there have been several issues with their paper since they released it. Of course, such an announcement is a massive breakthrough. So it's generated a huge amount of interest. But there are some issues. The first one is that their paper did not at any point mention the Meissner effect. So this idea of repelling the magnetic field was not actually seen, or at least was not reported. There wasn't the plot you'd expect to see with the Meissner effect of the magnetic fields getting thrown away from the elements. So they said that this material is easy to reproduce. So of course, a lot of people have jumped on this. 1 week later, where are we? Because last week I said, we expect to see answers within a week. So there has been a new paper, a new article about this at least once or twice a day since the announcement. There's an overwhelming amount of research being done on this. There is a Wikipedia page just about this material. The editors of this Wikipedia page are working very, very hard because they keep updating it every few hours as more papers come out. The material is called LK99, named after two of the authors and the year they started working on this, so it's been coming for a while. So where are we right now? No group around the world has yet been able to confirm that this material is a superconductor. What several groups have found is clear diamagnetism. This seems to be very much the case. There are videos going around online of the people reproducing the sample and it levitating, but not everybody trusts these videos because this is something that is very easy to fake in a video. And all of these videos are like somewhat grainy, where it would be easy to hide details. And no one yet has reproduced superconductivity with the Meissner effect and with all of the other properties that we want. So there have also been a bunch of theoretical studies that have shown that if you simulate this material in a computer, you can reproduce diamagnetic effects. But still, the key thing of the magnetic field lines going around have not yet been reproduced. Now, it doesn't mean that it is not a superconductor. It just means we haven't reproduced it yet. And it turns out that making this material is a lot harder than people expected. It's not something that you can just cook up in a day. It requires several steps. And a couple of the labs that have tried to reproduce it thought they had. But then when you do like a specific analysis of how things are moving inside this structure, it's not exactly the right match. So then these people haven't reproduced a superconductivity effect, and the Korean scientists have said, yeah, but this is not the same material. This doesn't match our material. So imagine someone can reproduce superconducting material but can't get a clean camera that is not grainy. Come on. So where are we currently? Nobody has reproduced superconductivity. Several people seem to have reproduced its diamagnetic effect, which is very cool. But also, a frog can do that. It is not a superconductor. Now, I don't want to downplay it because it is still a very cool thing. Diamagnets have a lot of applications as well. So what is missing now is figuring out, is this only a diamagnet, or is it also a superconductor? This is the step that we haven't yet done. People are trying. There have been a lot of studies on this in the last 2 weeks. It is a very cool material, whatever it is. And there's definitely some fun stuff happening there. Is it a superconductor? It's still too early to say. We still need more experiments. We still need to reproduce the original experiment in the right circumstances and actually show the Meissner curve that everybody wants to see, show that plot, show that effect. So right now, what we can say is they've definitely found something cool. It might be a diamagnet. It might be a superconductor, but we have not been able to reproduce that yet. So this is why I was talking about levitating frogs. So going back to my lovely drawn sketch with the fancy S and the diamagnet here, we can reproduce this in LK99. We cannot reproduce this yet. That doesn't mean people won't. But it is very cool. And I talked about this last week, and I'm talking about it again now, because personally, I think this is one of the most exciting things happening in physics. It's not my field. It's not something I personally work on or have worked on or plan on working on in the future. But the implications this has for people is very cool. And let's be negative here and let's say worst case scenario, they disprove that it's a superconductor and it's only a diamagnet, which is still very cool. The amount of interest this has generated is incredible. It's easy to get people interested with pretty space images. Like, look, we looked at a galaxy, we have a pretty picture. It's easy to get people interested. Superconductors are something that I feel is very difficult to get people engaged in. Like, why should you care about magnets other than magnets make frogs levitate? But this has generated so much attention and so much press and so much interest in the field that whatever happens, I think it's very exciting, and I'm really looking forward to see what other teams do. I'm trying to read all of the news that comes out about it and what's happening, and how they're going about testing it. So yeah, it's very, very cool, and it's an interesting topic, and it's not at all related to cosmology, but it's something that I can't not talk about because it is a major announcement in physics, a major step forward. And whatever the outcome is, it's a fun ride, it's a fun journey. It would be so cool if we do find a superconductor. I feel like, in general, everyone has had a bad couple of years. You know, the world is not in a great state right now. Most of it is our own doing. But this is the kind of thing that we need, right? This kind of discovery, this kind of announcement. There hasn't been such a massive breakthrough in physics in quite a while. So if it is an actual superconductor, that is very cool. If it's just a diamagnet or a material with diamagnetic properties, that is also cool. Not as cool, but still fun. So it is very, very fun, and it's interesting to follow. And that's why I wanted to tell you all about it. And it also gave me a chance to talk about levitating frogs. And why would I not want to talk about levitating frogs? Okay, there was the other question. Feel free to ask me more about superconductors. I can give hand-wavy explanations that somewhat approximate a good explanation, hopefully. But there was the other question of what's the status of Euclid. So I have to talk about Euclid. Euclid is an amazing telescope from the European Space Agency. It is set to measure. I credit the public's interest to ICP. They said water, fire, air, and earth. Magnets, how do they work? Yeah, magnets, honestly. Mystery. Magnets go. That's how magnets work. Magnets. Frogs levitate. That's how magnets work. I actually messaged two other physicists before the stream, like, how do I explain diamagnets? And we were like, frogs levitate. Go with that. So, yeah. Anyway, Euclid, European Space Agency, has created a new spacecraft called Euclid that is set to measure the distribution, like the location of galaxies out to a really far distance. This is a telescope that has been years in the making. It's years coming. And it was launched on the 1st of July. It's up there in space now. We launched this. It's an amazing mission. It is considered the make or break of dark matter and dark energy. Like, it's really going to either show that our understanding of dark matter is fine the way it is, or it's going to show that we have something wrong and we need to rethink things. So it's really cool. A lot of people say that Euclid is going to be the successor to Planck. So Planck is the telescope that mapped the CMB for us, the cosmic microwave background radiation, and gave us this amazing picture of the early light of the universe. Took me a whole 53 minutes today. Got to be a new record. So Planck is the satellite that gave us this map of the baby universe. It is the most incredible map we have. This really pushed us into an era of precision cosmology, where we can talk about the components of the universe with percent level knowledge. And Euclid is expected to be as big a deal for cosmology as Planck was. Euclid is going to measure dark matter and dark energy really far out. So it's going to be a really, really incredible experiment. And I'm really looking forward to getting Euclid data and playing about with it and seeing what's there. Also, as an aside, another like cool science thing that Euclid might do for us is give us a measurement of the neutrino masses. So neutrinos are these tiny subatomic particles zipping through the universe at ridiculous speeds, almost at the speed of light, but not quite. We know that neutrinos have mass, but we don't know how massive they are. It's very fun because this is one of the tiniest particles we know of, and we're going to use galaxies to measure, to like weigh these tiny particles. The way we do this is because there's so many of them. If they travel too quickly, they can actually disrupt galaxies. They can like wash out galaxies. So based on how quickly they travel, we know their mass. And we can use the fact that we can see galaxies of specific sizes and shapes to put limits on how massive the neutrinos could be, because if they're traveling too quickly or too slowly, they would disrupt galaxies. And this might give us a measurement of neutrino masses. So we're going to use galaxies to measure the mass of these tiny particles. That's really amazing. And that's just like a bonus thing that Euclid is going to do for us. It's not its main target. It's just like, oh, incidentally, I can do this while I'm out here. What is the status of Euclid? Euclid launched on the 1st of July. It was an incredible launch. It launched in the first minute of the first launch window, like not a single delay, not a single issue. It just went smoothly. And it was so smooth that they expect the telescope to last even longer than we expected it to, because there were no issues, everything deployed at the right time. It's like everything that went well did go well. Euclid is traveling to L2. So L2 is Lagrange point 2. Lagrange points are places in an orbit when you have two bodies. There are 5 points where you can have a stable orbit, where you can just like dump a satellite and it's going to stay there and not do much. One of this is if you have like the sun and the earth, there's always going to be 5 Lagrange points, but also between the earth and the moon, there's 5 Lagrange points. So the Euclid is sent out to Lagrange 2, which if you have sun, earth, Lagrange 2 is down like the other side. So sun, earth, Lagrange 2 is over here behind the earth as far as the sun is concerned. One advantage for sending it there is you can use the earth to block the sun, so that then you block out a big source of light and contamination, and then you can focus on the universe. Euclid reached L2 on the 31st of July, exactly as planned, as scheduled. It is now parked, or like in a stable orbit in L2, just doing its thing over there. And they already sent back the first light. So Euclid has first light. First light of a satellite or a telescope is when it first like turns on and looks at the universe for the first time, and we call this first light because it's the first light hitting the telescope. Euclid had first light on the 31st of July, and they already released some images. The images are not spectacular. They're not supposed to be. They're test images just showing like, look, we turned our camera on and here's what it saw. It saw something. This is cool. So everything is going well with Euclid. It's in L2. It sent back its first light images, which are not spectacular. They're just showing that it's doing its job. It's going to go well. Now we need real data from Euclid. So what can we expect? What's the timeline with Euclid? When are we going to get Euclid data? So what I'm telling you now is unofficial. I am not part of the Euclid team. I don't have insider information. This is just what I've heard and what I suspect is going to happen. At some point between now and the end of the year, we will get a deep field image from Euclid. So this is not one of its goals. It is not a JWST. It is not a Hubble Space Telescope taking deep field images. But the pretty images are useful to show people like, look what we can do. So there's probably, these are not what we call science images. They're like more of like, look, fancy pretty images we can do. We expect these fancy pretty images from Euclid before the end of the year. Again, these will not be of high scientific value, but they're going to be pretty. These will be released probably at some point before the end of the year, just proving that we can align everything, we can do everything. Then Euclid is going to take data for a series of years. The first data release that we expect is in early 2026. So about 18 months. 18 months? Is that 25? Early 25, I believe it is. At some point in 2025, we should get the first data from Euclid. Nice to see a non-depressed Gen Z. I am a millennial, thank you very much. I'm not a Gen Z. God, I'm a proud millennial. And yes. Anyway, we expect to get the first data release from Euclid probably in 18 months. And it's going to be so cool. And then there will be a period at first where the actual people involved, like the Euclid team, get first rights to use the data for a few months. And then they'll release it to the public, and then we can play about with the data and poke at it and see what we can do. And that's going to be so much fun. So yes, things are going well with Euclid is my takeaway there. And I just ignored messages for quite a while. So let me go back to the messages here. Okay, simple question. Is magnetism any different on Earth as opposed to space vacuum in any way? Well, magnetism requires some type of electromagnetic field. So it's not affected in any way by being on Earth or being in space. It should be the same in both cases. LK99 is a pretty cool name. Yes, it's catchy. You know, if you make a breakthrough and you get a superconductor, give it a catchy name. Otherwise, it's very difficult for people to get excited about it. This is true with galaxies as well. If I talk about NGC 9628, you have no idea what galaxy I'm talking about. If I say Andromeda, these are not the same galaxy. That did not match. That was a random number. Then it's like, aha, or you know, the sombrero galaxy. Then like, oh, it has a name. Things are more relatable when they have names. It's just the way things work. This is incidentally why all of my plants and all of my electronic equipment have names, but also that's a me thing. Also, magnet falling slowly through a copper tube is also a good example of diamagnetism. Yes, if you drop a magnet through a copper tube, it kind of slows down. It's a very cool thing. Like instead of dropping it, kind of slows down. The reason for this is a diamagnetism as well. And as you can tell, I have no idea how to pronounce diamagnetism because I always drop the A and just say dimagnetism, and that's not actually correct. So if you hear it pronounced a different way somewhere else, trust there's someone else. I think superconductors need zero magnetic force. Well, they need zero magnetic force inside the superconductor, but outside there can be magnetic field. This is the idea that they repel it. So inside the superconductor, there is zero magnetic field. CMB, yeah, it took a while. I found a way to slip in the CMB kind of, but it took a very long time for the CMB today. Every time I show the CMB, you want to ask the status of the neutrino background. We haven't measured it yet. I'm going quick fire answers because we have passed the 1 hour mark. We haven't yet measured the neutrino background radiation, but I'm hopeful that we will someday. Neutrino radiation background is like the CMB background, cosmic microwave background, but with neutrinos instead of particles of light. Also very, very cool. Okay, we did when is Euclid data available? All of the climate indicators going vertical could probably use breakthroughs for more efficient transportation and electricity transmission. Yeah. The climate crisis is the biggest threat humanity has ever faced, and we need to be dealing with it now. We should have been dealing with it 20 years ago. But it's not too late. We still need to be dealing with this. And a lot of people have now slipped into, oh, it's too late. We're going to do nothing. No, no, no. This should be everybody's focus right now. The charts currently are terrifying. The numbers for climate change are terrifying. And yeah, it's something we should all be paying a lot more attention to, and we should all be shouting about a lot more than we are. And I'm not going into the rant now because we're almost at the 1 hour mark. So one way of having a planet in a binary system would be to place it at one of the L points. Yeah, the problem is the L points are usually like between the sun and the Earth. Once you have a binary system where you have 2 stars and a planet, you suddenly have 3 bodies. And 3 bodies become a lot harder to compute because the gravitational field is just all over the place. So once you have 3 bodies, things get really messy. So finding Lagrange points in 2 bodies is easy. Finding Lagrange points when you have 3 bodies, very, very complicated. Okay, L3 and L1 between the Earth and Sun where people want to put moon dust. Yeah, so you have Sun, you have Earth. The Lagrange points are like one behind the Earth, which is L2, one behind the Sun, which I never remember, 2 up there, and like 2 kind of up there, and 1 in between. It's always hard to it's fun to calculate where they are and then to think, wait, how does this work? But yes, there are 5 Lagrange points in a 2-body system. A 3-body system gets a lot more complicated. Yes, I am indeed a physicist, not a climate scientist. Just to be clear on this, I am a physicist. Anything I say about climate science is based on looking at charts and interpreting it and listening to experts, but it is not my field of research. Also, I'm not a physicist who works on superconductors, so everything I said about superconductors is based on my understanding of superconductors. If I talk about the CMB, I'm talking from a position of someone who's worked on the topic. If I talk about dark matter, I've worked on the topic. If I talk about superconductors, it's I read up about it because it's a cool topic and I understand some of the physics at play and Fox levitate. Meant to compliment great content. Thank you. I'm glad you enjoy the content. That's always nice to hear. Diamagnetism, yeah, I guess that makes sense, but I think dimagnetism is nicer. If your car is heading towards a wall, there might come a time when it is too late to hit the wall, but there will never come a time where you shouldn't hit the brakes. Exactly. You might still hit the wall, but you should hit the brakes as soon as possible. Yes. That was your explanation for why I'm not depressed. Yes, I'm not depressed because I'm not a climate scientist, fair, but I'm a physicist, but in general, you know, I'm going to go on a random tangent now. The world is scary. There is a lot of terrifying shit happening. We have an ongoing pandemic. We have other viruses coming up. We have super mutated bacteria. We have the climate crisis, which is the biggest threat humanity has faced. There is so much destruction in the world. And yet, I still think the world is full of hope and optimism. And that is what I hold on to. And, the universe is an amazing place. And we're just a small speck of this, a small part of the universe, living on our little carbon planet over here in the middle of nowhere, just trying to appreciate the universe and enjoy what we have in life. And the world is scary, but we are in a world that has levitating frogs, and we might have just found a magnet that does cool things. And I think there is always hope. Climate change is an incredible threat, but I do genuinely believe that humanity can deal with this and we can get through it. We just need to act together now. But I genuinely believe there is reason to be hopeful and optimistic about the world. So yeah, I am not depressed. I know a lot of people struggle with that, and fortunately, I am not one of those. I have other mental health problems, but not that. But yes, I always try to be optimistic. And part of the point of Cup of Cosmology is to tell you about all of the cool stuff happening in the universe and out there, and that we can study. I do generally think there's a lot of reasons to be optimistic and hopeful, and hopefully I can convince you somewhat that the world is an amazing place and we are an amazing species. So we will get through this. That is my takeaway today. In a world with levitating frogs, how could you be upset? let that be my motto. In a world of levitating frogs, enjoy the levitating frogs. Incidentally, someone gave me a very cute frog sticker that hasn't yet migrated to my laptop, but I have a frog sticker and I love frogs. Okay, lots of tangents, lots of random stuff today, but some takeaways. Euclid is cool and doing a lot of cool science. We're going to get data in about 18 months, I expect. We may have found a superconductor, still working on that, still trying to figure that one out. But even if it's not a superconductor, it's still going to be very, very cool. And aliens have not yet visited us. They might do someday. We still haven't found any type of aliens, but it's also a fun topic. I know there were some other fun topics that we talked about. I just put a comment up on the screen. Always be kind to each other, because that is a good advice to live by. A lot of cool stuff happening in the world. A lot of cool stuff happening in science, and maybe we get a new superconductor soon, which would be amazing. Okay, so I've been talking an hour and almost 8 minutes now, so a bit over my usual thing. Do you think the universe prints more only when we look? I doubt that the universe cares about our own enjoyment, but maybe. It's like when you play a video game and you have the little map at the bottom of the screen, and more of it appears as you go and explore more places. I mean, in a way, that's what we do with the universe, right? We map out our universe as we go. We don't have an atlas of the universe at hand. We build it as we go. We are the map makers of the universe, at least of our corner of the universe, until we meet another map maker. On that note, this has been really fun today. It's been a lot of me rambling about random stuff, but it's been very, very fun. I am not yet sure when the next Cup of Cosmology is going to be. So, I've always wondered how people manage to block out like 10 weekends when you ask people for plans, and they're like, oh, next time I have free time is in 3 months. Like, how do you do that? But I realized recently that between now and October, I literally have one weekend that is not fully booked. So yeah, that is not at all overwhelming. Next week, I probably won't be able to do a Cup of Cosmology. I'm going to be at a wedding, and then I have family plans. I'm back in Germany visiting lots of people. The weekend after, unlikely to do a stream. The weekend after that, probably unlikely to do a stream. I don't yet know when the next Cup of Cosmology is going to be, unfortunately. But even if I do take a break for a couple of weeks, show's not going anywhere. It is coming back. It's just I have a lot of chaotic stuff going on. I might try to do one during the week at some point. If that's the case, I will put out an announcement on Twitter. And if you subscribe to the YouTube channel, you will always get a notification before I go live, because I schedule the events in advance. So you can always see when. I usually schedule them at least 6 hours in advance, so you can always see when I'm going to go live. On that note, if anybody here follows me on Twitter, just a general comment that my Twitter is not being used anymore except for Cup of Cosmology updates. So if you want to contact me, Twitter's probably not a good place anymore because it's just the hellscape that I'm trying to avoid. So it's just mainly used, it's only used for Cup of Cosmology updates for now. There will be more info soon about where you can find me for other science outreach that is not Cup of Cosmology in the works, coming soon. Expect an announcement soon on that. But yes, I don't know when Cup of Cosmology will be back, but save up your questions because we will be back at some point. And I hope that next time I'm on, whenever that may be, we'll have some clarity about the superconductor and more stuff to talk about. And I'm sure there will be a lot of cool science happening between now and then. So I hope to see you whenever Cup of Cosmology comes back. I don't know when that will be, but yes, I am on Mastodon. More on that soon. I'm setting more on Mastodon soon, but I love Mastodon, and there's going to be some updates there. So yeah, there's going to be more places where you can find me. I'm diversifying, as the phrase goes. Thank you everyone for joining. It's been really, really fun. Great to have you here as always. Great to have all the questions. You've all had really fun questions today. It's been great chatting to everybody. I hope to see you again at some point whenever I'm next back online. And I hope in the meantime, you all stay safe and take care of each other.